Hello students, a very good morning. So in yesterday class students we were discussing about the vectors, and there we have seen how many types of vectors we have, how can we denote it, and which of the laws we are using for the vector addition or subtraction. So there we have seen that we can use a parallelogram method, or we can use the triangle law of method to just add or subtract two of the vectors. Now let's move further in our chapter. So in the vector chapter here, a number of topics are still left. So first let's start today from the position vector in space. So what is position vector in space? So consider any of the particle is in space, then let at any instant t its position is p. So in this figure you can see now this is the position p, and whose position coordinates from three mutually perpendicular axes with origin at O, B, X, Y, Z. So with respect to this origin, you can see now three-dimensional space or coordinate system we have drawn. So this point P, its location can be written as X, Y, Z. Now the position vector of particle at P, that is given by this equation, r is equal to xi plus yj plus zk. So this is known as position vector to represent any of the point, and if we have to calculate the magnitude, then by this formula we can calculate magnitude. Now let's see next one, the displacement vector in space. So here suppose we have a particle p, and at any time now again it reaches to the point q. So in this figure, same figure, you can see p that is reaching to point q, and that has the points that are x1, y1, z1. So the position of vector p, point p can be written as r is equal to xi plus yj plus zk, and while the position of particle at q you can written by x1i plus y1j plus z1k. You know what is I, that is unit vectors, and x1 is what, that is magnitude along that direction. Now we can find out the displacement pq, because our particle is displaced from p to q. So pq can be obtained as the delta r, that is equal to r1 minus r. So what you have to do, you have to write down the value of now r1, you have to write down the value of r, and if you will solve it, then this is the value that we have obtained. So that is called the displacement vector. So finally the displacement vector delta r is obtained as in magnitude format. So that is in vector format, you can say na, delta r vector format. Now delta r in magnitude format, because there is the mod we have used. So this is root of x1 minus x whole square, then magnitude of this one y1 minus y whole square, then plus z1 minus z whole square. So in this way you can find out displacement vector and position vector very easily. So let's see one sample problem based on this one. So problem is given, if one of the vector is given a is equal to this one, then we have to find out first what is the magnitude of a. So magnitude of a, you know, if a is equal to axi plus ayj plus azk along the three axes, then that time the modulus of a, that is magnitude of a, is given by ax square plus ay square plus az square. Now in this way, let's compare our this equation with this equation. So we can find out what is the value of ax, ay and az. So you can compare and you can find out ax has value 2, ay has value 4, and az has value minus of 5. So let's put in this equation. So find out the magnitude of a. So magnitude of a is obtained as root of ax square, that is 4, ay square, that is 16, plus az square, that is 25. And now if you will solve, then you can find out root 45, that is the answer of for the magnitude. Now second one, the question is asked the direction cosine of vector a. So direction cosine is what, we have to find out the angle between axis, the component along x-axis and the vector a. So here you can see now cos alpha, this can be given by this one. Similarly cos beta and cos gamma can be written as. So in yesterday class, as we have discussed about the cosines, direction cosines of any vector, so by these formulas you can calculate direction cosines. So what you have to calculate? Cos of alpha. So cos alpha is equal to ax upon a, and ax we have just calculated, actually ax is not this one, yeah, this is cos alpha. So ax is equal to 2, and root of magnitude of a, that is root of 45. So this is our cos alpha. Similarly cos beta and cos gamma can be calculated easily. Now let's see the next concept, that is for the resolution of a vector. So let's see what is the resolution of vector. So it is the process of splitting a single vector into two or more vectors in different directions, so which together produce the same effect as it produced by the single vector alone. So the vectors into which the given single vector is splitted is called component vector. So like before we have seen, we are merging some number of components into one vector, that is called resultant vector. But when we are dividing any single vector into the number of components, then that time it is known as component vector. So for example, here you will see the resolution of vector. Just now I have told you this is the just opposite of the composition of vector. So if any vector r, that is represented by in this figure represented by OQ, then if a and b are represented by OP and PQ, then we can write by the vector triangular law, that is we can write OQ, vector OQ, this is equal to what? This is equal to vector OP plus vector PQ. Now you can see vector OQ is equal to R, vector OP is equal to A, and then vector OPQ is equal to B. So R can be written as A plus B. So it means that we can resolve R into two component A and B. Simple. So this is called the resolution of vector. So here next one, let's see some of the applications of resolution of vector, why we need to resolve the vectors. Like the first application is given, walking of a man is an example of resolution of forces. So whenever a man is walking, then that time he presses the ground with its feet backward by the force F at an angle theta with the ground in action. So you can see now this is the force F that is applied by our feet to the ground, and that is this is the angle theta that is made in backward direction with the horizontal. Then you know that whenever we are exerting some of the force on ground, then ground also exert the reaction force equal in magnitude of F in opposite direction. So it means you will see the value then R, so that is just opposite to this one. So this is R and this is now F. So here if we will just see, so if this is our F that is applied by our feet, this is angle theta, and this is now just opposite the reaction of this force that is due to ground we have got, we can write down. So as this angle is theta, then by geometry this angle will also be theta. Now we can resolve the R into two factor, the vertical component and horizontal component. So this the angle attached to the side, that is called horizontal, and the angle that is not attached, then that is called vertical. So horizontal one can be written as this is R cos theta. Similarly vertical one, here how can you find out? You can just make a parallelogram here, like in this figure you can see a parallelogram, and using this parallelogram you can just choose the right angle triangle, this one right angle triangle, and in this one cos theta, find out this will be equal to here this component, the base, this component will be equal to R cos theta. Similarly this component will be equal to R sin theta. So it means that R can be resolved into two components, the vertical component and the horizontal component. So vertical component is R sin theta, horizontal component is R cos theta. Clear, I think. Now let's see the second one here. and where actually we are using this concept of the walking of man. Whenever we are just discussing the concept of friction, then that time we need this resolution of vector. So later in law of motion chapter you will study this one. The second application of resolution of vector is it is easier to pull a lawn roller than to push it. So let's see why we can pull easily any lawn roller in comparison to push it. So here the pulling and pushing both one is given. So in this figure, whenever we are pulling, then that time we are applying force in this along this direction. That time force has two component, F cos theta and F sin theta, if theta angle it is making from this one, and its weight is working in downward direction. So that time in pulling, the effective weight of roller, this will be now W minus F sin theta, because F sin theta is in just opposite direction to W, so that will reduce the effective weight of roller. So in this case it means that due to the reduction in effective roller, it is easy to pull it. But let's see when we are pushing it. So then whenever we are pushing, then that time the force is applied along this direction you can see. Then this time F cos theta and F sin theta, two components we are getting. So F sin theta is supporting the weight of the roller now. So the effective weight of the roller will become W plus F sin theta in this case of pushing. So it means that the effective weight will increase now. So due to increment in effective weight, it is hard to push the roller in comparison to pull it. So I think this effect is now clear. We can easily understand by the resolution of vector set. Let's see the next concept, that is now how can we multiply two of the vectors. So the multiplication of vector is also done in different format than the normal algebraic rules. So this is now done by the two methods. So the first method of the multiplication is known as dot product or scalar product of two vectors. So what is the dot product of two vectors? Suppose two vectors A and B we have. So dot product of these two vectors are represented by A dot B. Here you can see now. So it is read as A dot B is a scalar which is equal to the product of magnitudes of A and B and the cosine of the smaller angle between them. So here whenever the dot product of two of the vectors we are taking, so that is equal to magnitude of both, first of all A and B, then that time what cosine angle between them, and this theta should be smaller angle between them. Like two of the vectors we have, suppose this is now vector A and this is now vector B. So here the angle between them is theta. So this angle should we have to take, not this one angle, because this is larger angle, we have to take the smaller angle. So this is this can be now expanded as A dot B is equal to AB cos theta. So this product is known as dot product or scalar product of the vectors. So after scalar product, A dot B always give us a scalar quantity. It can never provide us the vector quantity. So if we have to just interpret it geometrically, so let A be represented by OP. So OP you can see in this figure, this is now OP in this figure, and B is represented by OQ, and let theta angle between them is theta. So if we will draw a perpendicular QR on OP as in figure you can see now this one, then OR that should be equal to B cos theta. Similarly OS can be written as A cos theta if we will draw PS perpendicular on OS. So PS perpendicular on OS, where you can see that in this figure. So PS you can see on OQ we have drawn the perpendicular. So that time you can write this value. Now we will just take A dot B. So A dot B will be equal to A B cos theta, because here A will have the value now we can say that is equal to either we can write A dot B cos theta or we can write B dot A cos theta. So both are correct, and both way we are obtaining the same thing, AB cos theta. So in this way you can just understand The dot product of two vectors are also defined as the product of the magnitude of one vector and the magnitude of component of other vector in the direction of first vector. So let's see now some of the special cases. So in the case of in special cases, if we have the dot product of two unit vectors like I cap. So for I cap, as these are I is representing x direction, so both are representing the same direction, the angle between them will be now 0. So for the 0 angle, a dot b, from the rule it will be equal to now ab. So as you know, a is what? A is the magnitude of a, b is magnitude of b. So if we will take the magnitude of I, as I have told you, this is value equal to 1. So similarly the magnitude of I and I, that is 1. So it means after just taking dot product of I cap, then that will be equal to simple 1. Similarly j cap and k cap all are will be 1 now. Now the next one case is here, when two vectors are mutually perpendicular, then theta is equal to 90 degree. Then in that case this value will become now 0. So here it means that the dot product of two perpendicular vector is always 0. So if two of the vectors are perpendicular to each other, then that time the dot product will be now 0. So now you can write down this one value here for the perpendicular of two vectors. So here if two vectors are perpendicular, then that time due to cos 90 is equal to 0. So I dot j, j dot k or k dot I, all values should be equal to now 0. The third one rule is when two vectors are anti-parallel, this one, then theta is equal to 180 and cos theta is equal to -1. Clear, I think. For anti-parallel means if one is in this direction, second is one is in this direction, so they are called anti-parallel to each other. Then that time we are obtaining a dot b is equal to minus of ab. So just now we can see now only the directions change is occurring here. Now let's see the properties of dot product of two vectors. So the first of property of dot product of two vector is dot product or scalar product of two vector is commutative. Commutative means what? If you are multiplying a or you are taking product of two vectors as a dot b and then b dot a, both will be same here. Commutative means this one, means there is no effect whether you are writing a dot b, that is ab cos theta, or b dot a, ba cos theta, both are the same thing. Next one, second one, dot product or scalar product is distributive in nature. So you can distribute dot product over the addition or subtraction, like you can see here the b plus c is addition is given, and we are taking dot product with vector a of this b plus c vector. So then it is distributive, like dot product is distributive over b, then distributive over the c. Now third one, dot product of a vector with itself gives square of its magnitude. Like if you will just find out the dot product of vector with itself, so if was a dot a, this you have to find out. Then for this one, as our formula is a dot b is equal to ab cos theta, so this will be a into a cos of theta, and between the same vector theta will be obviously 0. So cos 0 it has value 1, so we will have the value a square. So this is our next property, as it is giving the square of itself or square of its own magnitude. Next one here, if you will have this kind of situation, if dot product of some lambda b you are taking, then this will be equal to lambda of a dot b, where lambda is the real number. Let's see now some of the examples of scalar product or dot product of two vectors. So the first example is work done. So work done is defined as the dot product of force vector and displacement vector. So if force vector is F, displacement vector is S, then work is defined as force into or dot product of force and displacement. Similarly, instantaneous power we are defining by taking the dot product of force and velocity, instantaneous velocity. So you can find out this one by using. Next one, like magnetic flux. So magnetic flux linked with any of the surface is given by the dot product of magnetic field and area vector. So in this way you can see now the dot product of two vectors that are scalar in nature. So work, power or flux, these are all scalar quantities. Now let's see next one case here, the dot product in the Cartesian coordinate. Like Cartesian coordinate means if we will just write down any of the vector in its component format. So you know you can write a is equal to axi plus ayz plus hzk is similarly you can write for b. Now you can take the dot product. So if you will take the dot product, then this one and this one you can write. Now you can take the multiplication of whole of the term. So after multiplication you will find out this value, because I dot I when or j dot j or k dot k, its value will be equal to 1. And if we are getting I dot j, j dot k or k dot I, then that time we will have the 0 value. So you can have the final this value ax bx plus ay by plus az bz. This is our or answer of, you can say, a dot b. Like here one question is given. So the first sample problem is a constant force this bracket term Newton produces a displacement of this meter, then what is work done? So work, you know, work is given by force into displacement. So the dot product of force and displacement means 2i cap plus 3j cap plus 4k cap, and dot product with the displacement, that is 2i cap plus 3j cap plus 4k cap. Now we have to take the dot product. So to take the dot product, simple, you can multiply these all, and after multiplication, as just now we have written the formula, that is the vector of product of, or sorry, dot product of a dot b, that was equal to ax bx plus ay by plus az bz. So ax in our question is what? Here w is equal to, now ax means fx, fy and fz. So fx has value here you can see now 2, and similarly here bx means the sx has value again 2, then again plus, then we have to write down fy, so this is 3, then multiplication with this one, that is 3, then again 4, and then multiplication with this 4. So this is now the case. How can we find out the work done? So final work done is equal to now 4 plus 9 plus 16, and you will just find out, then this is 29 joule. That answer we have obtained for the work done by this force to displace it by the meters. Now the second sample problem, if you will see, so if the magnitude of two vectors are 2 and 3, and the magnitude of their scalar product is 3 root 2, then find the angle between that vectors. So here this question is now something different. So here it is given that magnitude of two vectors means if vector a we have its magnitude is given 2, vector b we have its magnitude is given 3. Now next one, it is given the magnitude of the scalar product. So it means scalar product means a dot b, its magnitude is equal to 3 root 2. Now we have to find out the angle between them. So you know that a dot b in vector format, it is equal to ab cos of theta. So from here cos theta can be written as a dot b upon ab. So a dot b, that is given 3 root 2, and ab, this is 2 into 3. So final answer we have obtained, that is 1 by root 2. So 1 by root 2, as you know, this is equal to cos 45. So theta is obtained as 45 degree. So here the next type of product or multiplication of vectors is called vector product or cross product of two vectors. Means whenever we are doing the cross product, then what we are doing, we are writing the cross product in the in form of a cross b. So here a cross b, whenever they will use, then that time we will always get another vector, and that is equal to c. Now next one here, as just now I have told you how to just so this one, then a cross b is equal to c is equal to ab sine theta into c cap. C cap is what? To make ab sine theta as the unit one. So that's why we have just written a unit cap vector. So don't be confused by this one case. Now let's one next thing is given. Students, you will see now the direction of vector c, that is equal to a cross b. That's direction is given by the rules. That is, first rule is right hand screw rule, and second one is right hand thumb rule. So let's see what is right hand screw rule. So it states that if a right handed screw placed with its axis perpendicular to the plane containing the two vectors a and b is rotated from the direction of A to the direction of B through the smaller angle, then the sense of the advancement of the tip of the screw gives the direction of A cross B or C. So for which one, what you have to do? You have to just see this figure. So if you are trying to just rotate the screw, then that time the direction in which the screw is rotated, that is given us. If right hand you have to use and just rotate the screw, and then the direction of screw will give you the direction of C. Similarly, we can use the thumb rule. So if you will use thumb rule, now you can see if these are the directions of A and B, then the thumb is just means what you have to do, you have to use your right hand, you have to fold your fingers, and your fingers then the thumb that is at perpendicular angles to finger, that is representing the direction of C. So in this way, using thumb rule or using just a screw rule, you can find out the directions easily. Now next one here, if you will see the geometrical meaning of vector product of two vectors. So in if consider two vectors A and B are represented in magnitude and the direction by OP and OQ. OP you can see now, this one is OP, OQ is this one, A and B we have represented. Now if angle between them is theta, then we can make a parallelogram. So if we will make a parallelogram, then OQ, RP, O, this parallelogram we will have, and in this parallelogram we can draw a normal from Q to this QN on the OP. So this cross product A cross B, this is as equal to, you know, that is given by as sine AB sine theta into n cap. So here this AB can be written as OP, B can be written as OQ sine theta. So from here and from figure you can see in triangle O and Q. In this triangle you can find out the sine theta easily, and if you will find out the sine value of sine theta, then NQ can be found out, and you can write in place of OQ sine theta we can write NQ. So if you will write NQ, you will have already OP, then you can say OP into NQ is what? OP into NQ, that is the area of parallelogram OPRQ. So it means why as in the area of parallelogram, you know that that is equal to just product of adjacent just sides, and also we can write down the area in different ways, like here 2 times OP and Q upon 2, so we can write 2 times area of triangle OQP. So this is very easy method to apply or to utilize. Now next one, if you will see the properties or magnitude of vector product of two vectors. So here in the case of just a second, sorry. In the case of you will see now some of the magnitude magnitude of vector. Students, we can see now the magnitude of vector product, that is depending on that this is equal to the area of parallelogram whose two sides are represented by two vectors, and is equal to twice of the area of a triangle whose sides are represented by two vectors. So whether you can use parallelogram or you are using triangle law, that will give the same result. There is no change in that result, means area of parallelogram or 2 times area of triangle, both are the same thing. Now if you will just see some special cases of cross product. So in the special case of cross product, if two of the vectors are parallel or anti-parallel, so in the case of parallel theta will be 0, in case of anti-parallel theta will be 180. So a cross b, that will be equal to now ab, just ab. So because theta is now 0 or 180 degree. So for the unit vector, if you will just find out a I cross I, j cross j, k cross k, that becomes 0. Why? Because I cross I is equal to AB sine theta, means I into I sine theta, and angle between I and I is that time 90 degree. So that means cos 90 is 0. So find the unit vector will be, you can say now this value is equal to 0. Now the second one, when two vectors are now perpendicular. So when two vectors are perpendicular, then theta will be 90 degree that time, and sine theta will be 1. So a cross b will be equal to ab. So from here you can just found out what is the value of vectors and on which factor it is depending on. Now again you will see the properties of cross product, just like the dot product. Cross product are commutative in nature. Actually anti-commutative, not commutative, anti-commutative. Like a cross b we will have, then that can be written as minus of b cross a. Similarly, if you will see, then cross product we are calling it, that is dot distributive, and cross product of the vector is now associative. So with this topic, students, let's end our class here, as we have discussed a lot about the vectors, and then let's solve some of the numerical in next class. So for today let's end our class here. Thank you, students.